Example 5. Given Tn equals n plus 1 over 2 and Tn equals 2 over n plus 1, determine whether A, the sequence is arithmetic or not, and B, the sequence is increasing or decreasing. So there's two ways to work out this question. I think this version is the easier way, and I'll show you an algebraic version in a minute. So I'm just going to take Tn, which is n plus 1 over 2. So I'm just focusing on part 1 for the moment, so ignore part 2 for now. And I'm going to work out the first 4 terms. So I'm going to swap that n for 1, 2, 3, and 4, which will end up giving me term 1, term 2, term 3, and term 4. So we end up getting 1, 3 over 2, 2, and 5 over 2. So I have 1, 3 over 2, 2, 5 over 2, dot, dot, dot. Then I'm going to find the difference between the terms. So I'm adding a half each time. So since the common difference is the same, I know that this is an arithmetic sequence. And since it's going up, so it's positive, it's an increasing arithmetic sequence. This is the other way to work out that question. So I start off with what I was given, which is Tn equals n plus 1 over 2. So that's highlighted there in green. So I'm going to work out what Tn plus 1 is. So I'm going to take the n plus 1 over 2, and I'm going to add 1 to the n. So we end up with n plus 1 over 2, which is n plus 2 over 2. So Tn plus 1 is equal to n plus 2 over 2. So if you think about it, like Tn is the first term in the sequence, for example. It's not necessarily the first term, but if Tn was to represent the first term, then Tn plus 1 would represent the second term. Or if Tn represents the 6th term, then Tn plus 1 represents the 7th term. So Tn is a term, and Tn plus 1 is the next term. So the difference, so the common difference, will be Tn plus 1 minus Tn. So let's say this was the second term. Well, the second term minus the first term will give us the common difference. Or if this is the 8th term minus the 7th term will give us the common difference. So the next term minus the previous term will give us the common difference. So if you can get your head around that rule, that statement, the rest should be fine. So then we just sub in. So Tn plus 1, we're going to replace with n plus 2 all over 2. And then Tn, we're going to replace with n plus 1 over 2. And then since we have a common denominator of 2, we have n plus 2 minus n minus 1. The n's will cancel, and you're left with a half, which is a constant. So yes, the sequence is arithmetic because a half is a constant. And yes, it's increasing as a half is positive. So part 2 is done in the exact same way. So this is the first version of how you can work it out. So we take Tn equals 2 over n plus 1, and we're going to swap the n for 1, 2, 3, and 4 to work out the first, second, third, and fourth term of the sequence. So term 1 ends up being 1, term 2 is 2 over 3, term 3 is a half, and term 4 is 2/5. So we write them out in a list with commas in between. So 1, comma 2/3, comma a half, comma 2/5, dot, dot, dot. So then we find the difference between the terms. So to get from 1 to 2/3, we're subtracting a third. To get from 2/3 to a half, we're subtracting a 1/6. And to get from a half to 2/5, we're subtracting a 1/10. So we can clearly see that the difference is not the same. So it's a different number each time. So therefore it's not arithmetic. And we can see that it's going down. So the sequence is decreasing. So minus a third, it's going down by another 1/6, it's going down by another 1/10. So it's decreasing. And also we can just see from the numbers in blue, so the actual sequence itself. So it was at 1, it went down to 2/3, it went down to a half. So it's getting smaller each time. So it's decreasing. So then doing the same question out algebraically, we have Tn equals 2 over n plus 1, and Tn plus 1 equals 2 over n plus 1 plus 1, which equals 2 over n plus 2. So we took the Tn, which is 2 over n plus 1, and we just added another 1. So that's where the 1 plus 1 plus 1 came, the n plus 1 plus 1 came from. So if Tn, for example, is the first term, then Tn plus 1 is the second term. If Tn is the seventh term, then Tn plus 1 is the eighth term. So whatever term Tn is, Tn plus 1 is the next one. So if Tn plus 1, let's say, is the second term, and you subtract the first term, you're left with d, the difference. If Tn plus 1 is the 20th term, and you subtract the 19th term, you're left with the difference. So you can think about this whatever way you want. You can think about it in terms of this is the next term and this is the previous term. When you subtract, you're left with the difference. So this is a statement that you need to get your head around. I wouldn't learn it off as a formula as such. I would try to just understand the rule behind it and understand the statement. So Tn plus 1, we worked out to be 2 over n plus 2. So we replace that with 2 over n plus 2, bring down the minus. And Tn was given in the question, 2 over n plus 1. So we just bring down 2 over n plus 1. So then we just have algebra for the rest of the question. So we are going to put our denominators together with brackets around them because we need a common denominator. So n plus 2 goes down in our denominator, our common denominator with brackets, and n plus 1 goes beside it with brackets. So then n plus 2 divides into the common denominator and leaves us with n plus 1. So we have 2 times n plus 1. Make sure you include brackets. Bring down the minus, and then n plus 1 divides into the common denominator, leaving us with n plus 2. So we bring down the 2, and we stick on the n plus 2 with brackets. Again, make sure you use the brackets or it will go wrong. Multiplying out the brackets, we get 2n plus 2 minus 2n minus 4. No need to multiply out the denominator. 2n minus 2n will cancel, and 2 minus 4 is minus 2. So we have minus 2 over n plus 2 times n plus 1 is equal to d. So that's our difference. So since there's an n, well, there's two n's, but since there's an n in our answer, so since d contains an n, therefore it's not a constant. So if d is not a constant, Tn is not arithmetic. So Tn is not arithmetic because d contains n's. And then minus 2 over n plus 2 times n plus 1 is going to be less than 0 no matter what, because n is an element of the natural number set. So whatever you sub in place of n, you're always going to get a negative number because n is an element of the natural number set. So n represents the amount of terms, or the number of terms, and that must always be a positive whole number because you're talking about an amount of something. For example, if you were talking about the amount of desks in a classroom, you might have 30 desks in a classroom. You would never say you've minus 30 desks. And likewise, you would never say you've 30.5 desks or 30.7 desks. You're always going to have a positive whole number for an amount of something. So n will always be an element of the natural number set. It will always be a positive whole number. And no matter what you sub in place of n, you're going to end up getting an answer that's less than 0. So let's say you sub in 1. So you've got 1 plus 2, which is 3. And then you have 1 plus 1, which is 2. So your denominator, you're going to have 3 times 2, which is 6. And minus 2 divided by positive 6 is going to give you a negative answer. So minus 2 divided by positive 6 is going to give you minus a third. So n is always going to be positive when you sub in, because n represents an amount of something, a number of terms. But in this particular nth term, no matter what you sub in place of the n, you'll always get a negative answer. So therefore, our sequence is decreasing. And that should actually say negative, not positive. So n, when we sub in n is always going to be positive because n is an element of the natural number set. It's a positive whole number. But no matter what you sub in place of n, in this particular nth term, you'll always get an answer that's less than 0. So you're always going to get a negative answer. So therefore the sequence is decreasing.